All right, so here today we are doing law of sines. Now, previously, two classes ago, we learned how to use trig to solve for missing portions of right triangles. Today, you're going to learn that you can apply trig to triangles other than right triangles, which is awesome. You know, we've always been taught only right triangles you can use trig on. Well, there are exceptions, and today is one of them, law of sines. You can use the law of sines, and also next class we're learning law of cosines. You can use law of sines to solve oblique triangles. Now, the word oblique just means non-right triangles, right there. So we're going to learn about how you can solve for non-right triangles using trig. Now, there's a special law called law of sines that you can apply only to AAS or ASA triangles, and also there's a special case for SSA triangles, which we'll go over in the second portion of this class. Now, law of sines states that if you have a triangle ABC with side lengths ABC across from those angles, law of sines states that if you take the sine of the angle and put it over, whoa, no, what the heck? And put it over the side across from it, which in this case is side length A, this ratio will equal the exact same setup for the other angles and sides. So sine of A over side length A is equal to sine of B over the side across from it, little b, which is also equal to the last ratio, sine of C over the side length across from it, C. I drew that C kind of big. It looks like a big C. It's not. It's a C for side length C. This is law of sines. Now, when with law of sines, you will never use three ratios like this. You will choose two of them because, like, if you covered up that last sine of C over C, if you covered it up, you didn't look at it, don't cross it out, but I'm going to cross it out to show you. This is a proportion, and you can solve for a proportion easily, as long as there's only one variable. So let me get rid of that. Let's go ahead and try it. On number one, very first step and most important step is to make sure you can use law of sines on this problem. Now, obviously, it's not a right triangle, so I can't use just regular trig. Instead, I need to check, okay, can I use law of sines here? You check it by looking at the values given to you. So here, it gives you an angle, it gives you another angle, and it also gives you a side. We don't put a side length on x because that's not given. It's not an actual value given to us. It doesn't count. So this, if I'm reading these values in order, is an AAS triangle, which you can use law of sines on AAS triangles. So yes, I can use law of sines here to find the missing x value. So what you do is you pick one of the two angles given to you. So I'm going to start with 47. And you put it over the side across from it, 15. That's our first ratio. Our second ratio is the other angle given to us, sine of that angle, over the side across from it, x. And now the hard part's done. The hard part's done. Now this is just solving for x. How do we solve for x? Yes, well, yes, cross multiply. The reason you can cross multiply here is because you have a fraction or a ratio set equal to another fraction or ratio. If there hadn't been an equal sign between these two fractions, you cannot cross multiply. The equal sign is telling you you can cross multiply. So here, I'm going to show you the exact cross multiplication steps. However, on future problems, I'm not going to write it out because it's not needed. So let's do it. Cross multiply here, and you get 15. Well, let me erase that. You get 15 times sine of 104 set equal to x times sine of 47. All right, so what do I do to finish solving for x here? Yes, we need to get the sine of 47 off of the x. Right now it's x times sine of 47. So opposite of multiplication is division. We divide by sine of 47. Sine of 47's cancel on the right, and x is by itself. So now we can pull out our calculator. And in my calculator, I'm going to put 15 times sine of 104 divided by sine of 47. Now this is why I said this step isn't really needed, because you can just look at this step and see, all right, you're going to have to multiply 15 times sine of 104, but to get the sine of 47 off the x, you know you're going to have to divide by sine of 47. So in my calculator, I am going to put, I always put the whole number first, so I don't have to worry about closing the parentheses. And I also hit enter here. I don't just close the parentheses and put divide by sine of 47, just so I don't have to worry about what's being divided and what's not being divided. If I hit enter, it's the entire thing I multiplied divided by sine of 47. And you get 19.90. And our unit is centimeters, can't forget that, and I'm done. That's it. Okay, so let's do one more. Any questions on this first one? All right, number 2, again, our first step. So again, our first step is to figure out what type of triangle you're given. You're given an angle, a side, and an angle. So this is an ASA triangle. Now you can use ASA, you can use law of sines on ASA triangles. That's what this says. So we again can use law of sines here. We start setting this up, and we do sine of 42 over x, right? Sine of an angle over the side across from it. However, when I go to set up my second ratio, what issue do you see here? Exactly. The side length they gave us is not opposite the angle, the second angle they gave us. What can we do to fix this? How? Yes, exactly. You know, or you should remember from geometry, angles and triangles always add up to 180 degrees. That's like the basic law of angles in a triangle. It never changes. So, in order to find this third angle here, we do 180 minus 42 minus 63, and you get 75. So the ratio we can set up is sine of 75 over the side across from that, 28. It's impossible, especially because this is in a right triangle, but also because we're only given one side length. Without using some fancy math, it's impossible to find this side length. It's not possible. So that's why we instead found the angle measure, and then we can find this side length. And then once we have that side length, then we could find this side, ooh, that side length. But that's out of order. That's not really what we want to do. It's easiest just to find this angle and create this ratio. So now we are solving for x. So this is like what I was saying. I'm not actually going to write the cross multiplication steps. In my head, I'm just going to say, okay, it's 28 times sine of 42, but when I multiply x times sine of 75, I need to get that sine of 75 off of the x. So I'll be dividing by sine of 75. So what I put in my calculator is first the multiplication, 28 times sine of 42, but then I know I need to divide off the sine of 75. Oh, I didn't. I forgot to hit divide. Divide by sine of 75. And you get 19.396. The 6 makes the 9 round up, which makes the 3 round up to a 4. So this is 19.40. And my unit is feet, and I'm done. If you need to write the cross multiplication stuff, like you're not very good at visualizing things in your head, that's perfectly fine. Go ahead and write it out. It doesn't matter. I'm just trying to show those of you that can visualize things in your head that there are portions of math that you don't really need to be writing. You can just do it in your head, especially when you get to use a calculator. Are there any questions on these two problems? Thumbs up if you're good to go on this. Thumbs down if you would like another example. Awesome. All right. Wonderful. So now comes the tricky part, actually. Again, if you're confused by any of this, I know I haven't put it up for last class yet, but I will be putting up the keys so you can go back and look at more examples. All right. So now for the special case that I was talking about earlier. You can still apply law of sines to another special case when you have side, side, and then an angle, or ASS.